Hey everyone, and welcome back to the Hacker News Daily, where we break down the top stories that got the tech community talking. I'm your host, and today we're diving into yesterday's most engaging discussions from Hacker News. Out of 30 stories that hit the front page, we've pulled the 5 that really sparked debate, challenged assumptions, and got people thinking differently about technology and its impact on our lives. We've got everything from Steve Wozniak's philosophy on happiness versus accomplishment to the latest developments in ultra-compact AI models, and even Apple's creative legal workaround to bring back blood oxygen monitoring. What's fascinating about today's selection is how they all touch on this recurring theme of constraints and trade-offs, whether it's choosing happiness over wealth, efficiency over capability, or navigating legal restrictions with technical creativity. So let's jump right in. All right, so let's start with something that really struck a chord on Hacker News. We're talking 635 points and nearly 400 comments. Steve Wozniak came out with this statement: "Life to me was never about accomplishment, but about happiness." And honestly, reading through the discussion, you can see why this resonates so deeply with the tech community right now. In an industry that's become almost synonymous with hustle culture, billion-dollar valuations, and this relentless pursuit of the next big thing, here's Woz basically saying, yeah, none of that really matters to me. And the community response has been fascinating. It's like people are exhaling collectively, finally hearing one of the original tech titans say what many of them have been thinking. What really comes through in the comments is how consistent Woz has been with this philosophy throughout his life. Multiple people shared these personal encounters with him at airports, at lectures, just random meetings, and every single story paints the same picture. This is a genuinely kind, approachable person who treats everyone with respect. One commenter mentioned meeting him at an airport and Woz just chatted with them like a regular person. No entourage, no attitude, just genuine human connection. There's this interesting thread in the discussion comparing him to other tech leaders, and look, I don't want to pile on anyone, but the contrast people draw between Woz and Jobs is particularly striking. Where Jobs was famously demanding and often harsh, Woz represents this completely different path, proof that you can be instrumental in changing the world without becoming consumed by ego or wealth accumulation. Speaking of wealth, there's this brilliant anecdote someone shared about Kurt Vonnegut and Joseph Heller at a billionaire's party. Heller says he has something the billionaire will never have: enough. And that perfectly captures Woz's attitude. People in the thread are pointing out that Woz was content with his $10 million from Apple. Can you imagine? In today's world where tech founders chase that tres commas club like it's the holy grail, here's someone who said, you know what, this is enough for me to be happy. Now, there was one interesting counterpoint in the discussion. Someone argued that accomplishments actually lead to happiness, that the dichotomy Woz presents is false. And honestly, that's worth considering. But I think they're missing Woz's point. He's not saying accomplishments are bad. He's saying that making them your primary goal, your identity, your measure of self-worth, that's where you lose the plot. The timing of this hitting the top of Hacker News feels significant too. We're in this moment where the tech industry is doing some serious soul-searching. Layoffs everywhere, the hustle culture burning people out, AI raising existential questions about what we're even building toward. And here's Woz, who helped start it all, essentially saying, hey, maybe we've been optimizing for the wrong metrics this whole time. What I find most powerful about this is that Woz isn't some failed entrepreneur giving sour grapes advice about happiness. This is someone who literally co-founded Apple, who could have been one of the richest people on Earth if he'd played his cards differently. And he's saying he has zero regrets about choosing happiness over wealth accumulation. That's a pretty profound statement coming from someone who actually had that choice to make. The discussion thread really drives home how rare this attitude is in Silicon Valley today. People are almost surprised by it. Like, wait, you can be a tech legend and not be obsessed with world domination? You can create revolutionary technology and still prioritize being a good human being? It shouldn't be revolutionary, but in today's tech landscape,
It kind of is. Now, speaking of optimizing for different metrics and making trade-offs, let's shift to the world of AI, where developers are having some fascinating debates about whether bigger is always better. Yesterday saw not one, but three major AI stories hit the top of Hacker News, each approaching the question of model efficiency from a completely different angle.
First up, we have this wonderfully provocative question. What's the strongest AI model you can train on a laptop in 5 minutes? And I love this because it's one of those questions that sounds almost ridiculous at first, but actually reveals something pretty profound about how we think about AI development. So this developer decided to tackle what they openly admit is a silly question. Can you train a meaningful AI model on a MacBook Pro in just 5 minutes? And yeah, they actually did it. They managed to get a 1.8 million parameter GPT-style transformer up and running, trained on about 20 million tokens from the Tiny Stories dataset, achieving a perplexity of around 9.6. Now, for context, that's tiny compared to what we're used to hearing about, right? We're talking models with hundreds of billions of parameters these days. But here's where it gets interesting. The whole experiment reveals these fascinating trade-offs that you don't usually think about. Like, when you only have 5 minutes, you literally can't push enough data through a large model to make it worthwhile. The author found it's actually better to train a 1 million parameter model on 4 million tokens than to try cramming a billion parameter model with just 4,000 tokens. It's this weird optimization problem where time becomes your absolute constraint, not compute power or memory. And yeah, the author acknowledges the obvious. Anyone who can afford a MacBook can just rent some H100 GPU time for pennies and get vastly better results. There's no real-world scenario where you absolutely must train a model in exactly 5 minutes on consumer hardware. But, and this is what I find compelling, the comments section on Hacker News really ran with this idea in some unexpected directions. One commenter made this brilliant comparison to biological research. They said, look, we study fruit flies and E. coli not because they're the most complex organisms, but because they're simple enough to understand completely while still teaching us fundamental principles. Same thing here. These tiny models might actually help us understand what's really going on inside the massive ones we can't fully comprehend. There was also this whole thread about changing the metric entirely. What if we measured training time in minutes? What if we measured it in joules, actual energy consumed? Suddenly, you could compare training on a laptop versus a data center GPU in a way that actually means something for sustainability and efficiency. One person pointed out that their M1 Mac uses about 30 watts, so 5 minutes would be roughly 9,000 joules. That's a soda can's worth of energy creating something that can generate coherent text. Kind of mind-blowing when you think about it that way. But here's what really struck me. Several commenters were talking about practical applications that aren't as silly as they first appear. Imagine you're building a customer service bot for a small business. Do you really need GPT-4's capabilities to answer questions about store hours and return policies? What if you could train a specialized micromodel on demand, tailored exactly to that business's needs in the time it takes to make a cup of coffee? There was even this interesting pushback from one commenter who suggested that for such tiny models and short training times, you might as well just use old-school Markov chains. And honestly, they might have a point. At this scale, are we adding complexity for complexity's sake? The whole discussion really highlights something I've been thinking about lately. We're so focused on the race to build bigger and bigger models that we might be missing opportunities at the other end of the spectrum. Edge computing, IoT devices, situations where you need quick adaptation rather than broad knowledge. There's a whole unexplored space here. And speaking of exploring the smaller end of the AI spectrum, Google's taking this idea even further with their new Gemma model. Google just released their new Gemma 370M model, and this one's really fascinating because it's taking a completely different approach to what we usually see in the AI space. While everyone else is racing to build these massive trillion-parameter monsters, Google's going in the opposite direction with this tiny 270 million parameter model that they're calling hyper-efficient.
Now, here's what's really wild about this. They've made some seriously unconventional design choices. Out of those 270 million parameters, they're using 170 million just for the embedding layer, which is the vocabulary essentially, and only 100 million for the actual transformer blocks that do the thinking. That's like, imagine building a car where the trunk takes up 2/3 of the vehicle. It sounds crazy, but there's actually some method to this madness. See, Google's betting that for these ultra-compact models, having a massive vocabulary of 256,000 tokens matters more than having deep reasoning capabilities. And when you think about it for specific applications, like maybe you're building a medical device that needs to recognize tons of specialized terminology but doesn't need to write poetry, this could actually make sense.
The Hacker News crowd, though, they're having a field day with this one. The discussion has 244 comments, and it's pretty divided. On paper, Google's claiming state-of-the-art instruction following from models of this size, specifically on something called the IF-eval benchmark. But when actual developers started testing it, oh boy, people are reporting some genuinely hilarious failures. One user asked it to list mountains, and it started naming random objects. Another tried basic sentiment analysis, and it was just completely off the rails. There's this interesting exchange where the model lead, someone going by Canyon289, jumps into the thread to defend it, basically saying, look, you're using it wrong. It's designed for fine-tuning, not general use. And that's fair, but users are pointing out that even smaller models like QN's 0.6 billion parameter model are crushing Gemma out of the box. And that's even when QN is quantized down further. What I find really interesting here is the bigger picture. Google's not just releasing one model, they're building this whole ecosystem. They've got Gemma 3 for different hardware tiers. There's the QAT version for cloud and desktop, Gemma 3N for mobile devices, and now this 270M for ultra-low power applications. It's like they're creating a full product line from economy to luxury, while OpenAI and others are basically building Ferraris exclusively. The community reaction is telling us something important about where we are right now with AI. There's clearly huge demand for these tiny, efficient models that can run on device. People want AI in their smartwatches, their IoT devices, their cars. But there's also this expectation that even tiny models should be somewhat competent out of the box. And that tension between size, efficiency, and capability, that's the real challenge everyone's trying to solve. Some developers in the thread are actually excited about the fine-tuning potential. They're talking about using it for classification tasks, named entity recognition, specific domain applications where you can train it on your exact use case. And for those scenarios, having that massive vocabulary could actually be a huge advantage. You can handle specialized terminology without having to do weird tokenization tricks. But here's the thing that nobody's really talking about. Google says this model family has been downloaded over 200 million times. That's massive adoption, even if people are complaining about performance. It suggests there's this huge silent majority of developers who are finding ways to make these models work for their specific needs, even if they're not perfect for general chat applications.
The whole situation reminds me of the early days of mobile processors, you know? Everyone complained that they were underpowered compared to desktop chips, but they enabled this whole new category of applications we couldn't even imagine before. Maybe that's what we're seeing here with these ultra-compact models. Not a replacement for GPT-4, but something entirely different that'll enable AI in places we haven't even thought of yet. But you know, whether we're talking about tiny models or massive ones, there's a bigger question the community's grappling with. Can these things actually build software? And that brings us to our next story. Why LLMs can't really build software. This one pulled in 481 points and nearly 300 comments. And honestly, the discussion is way more nuanced than you might expect from the title alone. So here's the thing. We're at this fascinating inflection point where everyone's trying to figure out what LLMs can and can't actually do when it comes to writing code. And the community is seriously split on this one. You've got one camp saying these models are fundamentally limited. They're just pattern matching, without any real understanding of what they're building. But then you've got folks in the trenches who are like, wait a minute, I'm literally shipping apps with these things right now. One of the most compelling arguments in the discussion is about mental models. Several commenters point out that when you're debugging something complex, you need to hold this entire architecture in your head, right? You need to understand not just what the code does, but why it does it, how different pieces interact, what the edge cases are. And the argument goes that LLMs just can't do that. They're essentially doing sophisticated pattern matching. They see a bug, they match it to patterns they've seen before, and they suggest a fix. But they don't really understand the underlying system. But then, and this is where it gets interesting, you've got people like Andrew Mutz jumping in saying, hold up, I'm using C-Line with Claude Sonnet 3.7, and this thing is reasoning about test failures just fine. They're claiming it works as well as a junior engineer when you give it proper instructions. And Magisman drops this bombshell that they've published 2 iOS apps of moderate complexity using Cursor and O3. Not prototypes, not toy projects, actual shipped apps in the App Store.
What I find fascinating is how many people are comparing LLMs to junior developers. And that comparison really resonates, doesn't it? Like, think about a fresh grad on your team. They can handle well-defined tasks, they can write that CRUD endpoint you need, they can fix simple bugs. But ask them to architect a distributed system or debug a race condition that only happens in production under load, that's where they struggle. And that's exactly where people are saying LLMs hit their wall too. There's also this whole conversation about tooling that I think is super important but kind of gets overlooked. Multiple commenters are pointing out that maybe the problem isn't the LLMs themselves, but how we're trying to use them. We're stuffing them into chat interfaces when what we really need is deep integration with our IDEs, our testing frameworks, our CI/CD pipelines. One person made this great point that we're trying to use them like magical code genies, instead of what they actually are, really sophisticated autocomplete on steroids. The cynical take here is that we're seeing the classic hype cycle play out. We get this new technology, everyone thinks it's going to replace programmers next Tuesday, then reality sets in, and we realize it's a tool with limitations. But I don't think that's quite right either. What strikes me about this whole debate is that both sides might actually be correct. The skeptics are right that current LLMs can't architect complex systems or truly understand code the way humans do. But the optimists are also right that these tools are already useful for certain types of development work. It's not binary. It's not LLMs will replace all programmers or LLMs are useless for real work. The reality is somewhere in that messy middle. And honestly, that messy middle is probably where the interesting stuff happens. Because if LLMs can handle the routine stuff, the boilerplate, the simple CRUD operations, the basic refactoring, maybe that frees us up to focus on the actual hard problems, the system design, the performance optimization, the tricky business logic that requires real understanding. The community seems to be converging on this idea that LLMs are tools, not replacements. Really powerful tools that are getting better fast, but tools nonetheless. And like any tool, they're great for some jobs and terrible for others. The trick is figuring out which is which. Now, speaking of technical workarounds and creative problem solving, let's wrap up with a story that shows how even tech giants sometimes have to get creative with their constraints. Story 5. Apple Watch Blood Oxygen. Apple just announced they're bringing back blood oxygen monitoring to Apple Watches in the US. This is actually a fascinating story about patents, technical workarounds, and, well, whether this feature even works properly in the first place. So here's what happened. Apple just announced they're bringing back the blood oxygen monitoring feature through a software update, iOS 18.6.1 and watchOS 11.6.1 for the Series 9, Series 10, and Ultra 2 models that currently don't have it.
But here's the really interesting part. They're not bringing it back the way it originally worked. Instead of processing the sensor data on the watch itself, they've completely re-architected it to process everything on your paired iPhone. The results then show up in the Health app's respiratory section. This is all thanks to what Apple cryptically calls a recent U.S. customs ruling, which suggests they've finally found a way around their patent dispute with Massimo. And honestly, this workaround is kind of brilliant from a legal standpoint. By moving the processing off the watch, they're essentially changing the fundamental architecture of how the feature works, which apparently sidesteps whatever specific patent claims were causing problems. But here's where the community reaction gets really interesting and honestly pretty brutal. The Hacker News crowd is basically asking, wait, why do we even care about getting this feature back? Turns out a lot of users have been finding the Apple Watch's blood oxygen readings are, let's just say, not exactly medical grade. We're talking about people getting readings as low as 80% when they're perfectly healthy, numbers that would normally have you rushing to the emergency room. Meanwhile, a $10 fingertip pulse oximeter from the pharmacy gives them a normal 98%. One commenter made a point that really stuck with me. They compared this whole situation to how we used to miss IR blasters on phones. Remember those? We thought they were essential. And then, well, we just moved on. Maybe blood oxygen monitoring on a smartwatch is similar. Sounds great in theory, but in practice, if you really need accurate readings, you're probably better off with dedicated medical equipment anyway. The technical limitation of needing your iPhone nearby is another wrinkle. Think about it. One of the big selling points of the Apple Watch, especially the cellular models, is that you can leave your phone behind when you go for a run or swim. But now, if you want blood oxygen readings during exercise, well, hope you've got pockets for that iPhone. It's a compromise that really undermines one of the core use cases of the watch.
What's really fascinating about this whole saga is the debate it sparked about patent law and innovation. Some folks are viewing Massimo as the bad guy here, just trying to extract money from Apple without actually offering consumers anything valuable. Others are saying, hey, they invented something, they deserve to protect it. But then you've got people pointing out that both companies are basically exploiting technical legalities here. Apple with their processing workaround, Massimo with their patent claims. The timing of this update suggests Apple's been working on this solution for months, probably as a contingency plan from the moment the patent dispute started. It's a reminder that in the tech world, legal battles and engineering solutions often go hand in hand. Sometimes the most innovative solutions come not from trying to build the best product, but from trying to navigate around legal roadblocks. You know what I find most telling? The fact that Apple went through all this trouble, redesigning the entire architecture, dealing with customs rulings, implementing this iPhone-dependent workaround, all for a feature that many users say doesn't even work that well. It really shows how much these companies value feature parity and checking boxes on spec sheets, even when the real-world utility is questionable at best. But hey, if you're one of the people who's been missing this feature, it's coming back. Just maybe keep that $10 pulse oximeter handy as a backup. And that wraps up our dive into yesterday's top Hacker News stories. What I find fascinating about today's selection is how they all, in their own way, challenge us to think about what we're optimizing for, whether it's Woz choosing happiness over billions, developers questioning if we need massive AI models for simple tasks, or Apple engineering around patent disputes for a feature that might not even work that well. They all ask us to consider, are we solving the right problems? Are we measuring success by the right metrics? These were the 5 stories that rose to the top out of 30 that appeared on Hacker News yesterday, generating over 2,800 points and nearly 1,400 comments combined. The tech community clearly has a lot on their mind right now, from the philosophy of success to the practical limits of AI, and everything in between. Thanks for joining me for another episode of Hacker News Daily. If you enjoyed this deep dive into yesterday's top stories, make sure to subscribe so you don't miss tomorrow's episode. Until then, keep questioning, keep building, and maybe, like Woz suggests, optimize for happiness along the way. I'll catch you tomorrow with the next batch of stories that get the tech world talking.